And welcome to the Smash News Network, least busted name and news. We've got the largest solar flare we've seen in quite a while. 2 coronal mass ejections headed our way, and more. Coronal holes, sunspot 2882 producing some activity here. Right here, this bright spot, it's sunspot 2882. 2 coronal mass ejections headed Earth's way. One we expect to arrive midday tomorrow. The other in about 3 days. Here's another wavelength from the Solar Dynamics Observatory. Oh, what you want a close-up of that? Is that the deal? You want a close-up? Okay. That's ionized iron, by the way, 171 angstroms. You could call it the low corona. Spectacular imagery there. So again, there is another coronal mass ejection headed our way. We're going to look at the viewpoint from Lagrange point 5, where stereo A is located, and Lagrange point 1, where the SOHO-LASCO C3 is. The SOHO-LASCO C3 at Lagrange point 1 is the pane on the right. And the stereo A core 2 coronagraph is what you see on the left. That's located here, which puts the Earth off to your right. So there you go. Another Earth-directed coronal mass ejections. That's 2 in only a couple of days. You can see this halo forming around the LASCO C3 coronagraph, an indication that it is headed directly toward Lagrange point 1, the gravitational equilibrium point in between the Earth and the Sun. How about some more imagery? Here's a colorized magnetogram, and you can see sunspot 2882 perhaps has gotten more complex here. This leading umbra now, it's now basically reversed its polarity, as this now has a leading south pole umbra to its north, significantly increasing the likelihood of additional major solar flares and coronal mass ejections. We'll get to the M-class flare momentarily. Here's a composite image. This is 94 and 193 angstroms. A bit of a custom composite image. Quite spectacular activity there. Some coronal holes south of that area as well. We'll get to that momentarily. Also, here's a close-up in this composite wavelength. Yowzers. Compelling imagery on today's video. The radio flux has come up to 92. And for you new viewers, the 10.7 centimeter radio flux is a radio signal that comes from the sun. It's proportional to the sunspot number, and it comes from this portion of the sun right here, the upper chromosphere and lower corona. Here's a 1-year chart of that. The black line is the radio flux. And let's take a look at the Space Weather Enthusiast dashboard. NOAA is forecasting a brief period of geomagnetic unrest late on October 11th, and that's all we see. We're expecting to see a coronal mass ejection strike midday tomorrow, and another one late in the mid to late day on the 12th. So anyway, that's the NOAA forecast. There is modeling for this already. You can go look at it at the Space Weather Enthusiast dashboard. I'm not going to spend a lot of time looking at this, but you can go check it out yourself. Again, it's at the Space Weather Enthusiasts dashboard. Global seismicity here, no major quakes over the past 24 hours. Let's take a look at the map and scroll up the list here. So some quakes in the South Sandwich Islands as well as the Western Pacific there. Australia actually saw a 4.9. Leave us a comment if you felt that quake. I think that's a pretty unpopulated region. So a couple 5+ magnitude quakes there around the South Sandwich Islands region, probably the most seismically active portion of the planet. What do we have here? There's a 5.1 at Iran. Some quakes in the Caribbean as well. There's one near Japan. Looks like the largest of the past 24 might have been this 5.6 at Peru. 5.6 magnitude quake there at Peru, happening at 4:47 this morning on October 9th. Also a 5.6 there in between Kamchatka and Japan. So no major quakes there, nothing over a 6 magnitude. Let's check out the latest in volcanoes. La Palma still erupting, 10,000-foot ash plume produced by the La Palma volcano over the Canary Islands. Suwanosejima, flight level 070, 7,000-foot ash plume from Suwanosejima. Kadavar now back on the list, producing a 5,000-foot plume of volcanic ash. Popocatépetl, no volcanic ash observed. Don't assume it's not erupting. An attempt to do a square dance around the caldera. Fuego in Guatemala exploding, 16,000-foot ash plume there. Revenador exploding, 16,000-foot ash plume over Ecuador. Sabancaya exploding, 24,000-foot ash plume over Peru. Nevados de Chilean continues to explode, 12,000-foot ash plume there. Please don't pole vault the caldera no matter how bad things get. If you're going through hell, keep going. And if you'd like to celebrate the dimension of the year, unanimously voted 2020, the dimension of the year, hell, pick up some merch. You can find it at our merch shop, which is linked below this video as well as at smAsho.com on the homepage. Respect existence or expect resistance, universum liberate, forgive, remember, and hold accountable. Also, make Earth not suck again. It's up to you. And I'm currently wearing the hat. Hopefully you can see that. Make Earth not suck again. It's not up to giant heaving bureaucracies that can't even get out of their own way. It's up to people just like you. So pick up some merch, tell your friends and foes about this basic fact of existence itself, and help to Mensa. Make Earth not suck again. Or perhaps you'd prefer to Mansa. Make America not suck again. I don't know. Maybe you're concerned about making America not suck again in order to make the rest of the world not suck again, as America is the global leader in all too many things. So yeah, universum liberate, folks. Universum liberate. The merch is spectacular. The print quality is ridiculous. You'll love it. Welcome to the Neo Renaissance. Visit the homepage, smAsho.com. Visit the links below the video. Support the channel financially. Become a member of the Smash team, perhaps. You'll get all sorts of things that our Patreons never got to see. So if you're still a Patreon, cancel your Patreon and become a member of the Smash team today. Post haste. So here's the GOES magnetometer over the past 3 days. Nothing to write home about there. Although there is some plasma headed our way. There's also a coronal hole wind stream on the way. There's a pretty well-defined coronal hole now facing the Earth. We'll get to that in a moment as well. First, the magnetic environment of the heliospheric current sheet. And there is a South Pole current sheet on the way, assuming nothing suddenly changes. We can expect to be in a South Pole current sheet by tomorrow. There's the latest image, South Pole current sheet shown here in red. North Pole shown in green. Yes, the solar polar fields charge up. They polarize the plasma in the current sheet. Here's a line of sight view of the same data, essentially. It also shows you the solar magnetogram. And you can expect to see this blue line swing farther northward as sunspot 2882 rotates right into the Earth-facing zone there. Likelihood of large flares now quite high. It's a solar flare and coronal mass ejection warning reestablished, folks. So here's a line of sight coronal hole plot, and those coronal holes facing the Earth at the moment are North Pole oriented, I would say. And this imagery also shows you the sun's B field in blue. Those blue potential field surface source lines are the sun's B field. It's all part of the National Sunspot Observatory. It's some of the most important data that we have in terms of solar forecasting. So here's a 193 angstroms view, the full disk SDO past 24 hours or so. You can see how well defined that coronal hole south of sunspot 2882 indeed is. There should be a high-speed coronal hole wind stream showing up from that soon. Check out the transverse waves spreading across the entire sun after that flare happened. A massive reverberation on about 2/3 of the Earth-facing disk. That's what an M-class flare can do, folks. So here's your solar flare monitor and your detected sunspot groups. Detected sunspot groups. I can't say it fast. I don't know why. Anyway, sunspot 2882 remains beta gamma class. We showed you that leading South Pole umbra as it's getting pretty weird up there in the northern hemisphere of the solar disk. Solar flare warning, coronal mass ejection warning are in place. And there you can see that flare. The peak flux happened at 6:30 Universal Time. Just about 6:30, maybe 6:40, something like that. And there's the propagation of that major flare. It would have caused some radio blackouts over places like Africa and Western Europe, actually. There's the proton flux, as that did not produce any relativistic particles, at least none that have arrived yet. Did you know that relativistic particles can show up at the Earth geospace as quickly as only 30 minutes, meaning that those particles will be traveling at about 25% the speed of light? It's true, folks. None have struck recently. That's the 3-day GOES proton flux. Next, we'll move on to the real-time solar wind, and we did actually see a coronal mass ejection here. A little tiny baby coronal mass ejection struck. The density wave only made it up to about 15 protons per cubic centimeter. The speed only spiked to about 416 kilometers per second. It was very brief, but that is certainly a signal of a CME there. The change in the temperature and the density and the velocity all at once. Current conditions are very slow solar wind. Check it out, 279 kilometers per second. That's one of the slowest solar wind speeds we've ever reported on our daily space weather videos. Solar wind density about 8 protons per cubic centimeter. There's a global geomagnetism chart known as the KP index, KP2. And it's largely at 2 just because of that negative BZ. You can see we have a strong negative BZ component in the top pane there. Total field BT of 5, BZ of -4. Next, the geospace over the past 4 hours. Again, a very slow solar wind coming in at the moment. And a fairly homogeneous pressure, at least over the first 2 hours of this magnetohydrodynamic model here. And you can see that little minor coronal mass ejection striking there. Great example of a coronal mass ejection strike there on the Geospace Magnetosphere movie, a very minor one. And then subsiding in magnetohydrodynamic pressure. Next, looking at ground magnetic perturbations, changes to Earth's B field, geospace delta B. This one is in nanotesla, which is magnetic flux density as opposed to magnetohydrodynamic pressure. We see some pulses coming out of the Western Pacific here. And since there's a geomagnetic excursion going on, we're going to let this play through as it's refreshed. We want to show you the latest data. Maybe it'll make you less frightened of geomagnetic excursions, which are things that are probably occurring at all times. It's like the climate. It's never static, but always cyclic. Anyway, like the last frames, that's 4 hours of data there. Our other Geospace Magnetosphere movie. Next, we're interested in making sure you know where stuff is. And oh my God, we've got Mercury and the Moon and the Sun and Mars and Earth all in a line. You know what that means, don't you? It means absolutely nothing. Let's advance this 1 week. There's where things will be in a week. Don't be weak. Understand astrography. Congratulations on realizing our channel exists, by the way. Next, looking at the situation above my head, I'm using in-the-sky.org. I've faced my star chart to the south. I'm located in Lehigh Valley, Pennsylvania. If you want to make your own star chart like this, this is the all-sky chart. We've also drawn in the ecliptic and the galactic plane. Continuing on to a brief cosmology segment. Let's blast through it. And let's see what's going on at Sagittarius A star. So here are the outputs of the galactic core of the Milky Way galaxy. If you're scared of Sagittarius A star, for God's sakes, take an astronomy class. Learn something about the structure of the galaxy. Don't be scared of the galactic core. Sagittarius A star isn't scary from 40,000 light years away, certainly not in the orientation at which you are with respect to it. But anyway, once again, there are the X-ray outputs from Sagittarius A star. You can look up your favorite objects here, if you like, at the Neil Gehrels Swift-Bat X-ray Observatory. The one I look at most commonly is Cygnus X3, and you can just do a search for your favorite object. And there's Cygnus X3, otherwise known as Deneb. It's just the most intrinsically luminous object visible from our solar system. No big deal. There are the X-ray outputs from Cygnus X3. The tail of the swan, Deneb. Did you know that the tail of the swan is where the stork references come from? Yeah, Deneb. It's probably the most popular star in human mythology. If you want to read all about it, head to our forum at smAsho.com/forum. There's a whole cosmology thread in the cosmology forum about Cygnus X3, the celestial pole star at the other end of the precessional cycle, Deneb, otherwise known as Alpha Cygni. It's got many names, and it's one of the only known cosmic ray point sources. Here's the astronomy picture of the day showing you 51 Pegasi, which is located at about 50 light years. Yeah, you're seeing 50-year-old light there from 51 Pegasi. You can look at it yourself if you like at apod.nasa.gov. And let's talk about an interesting object here. It's Hamilton's object. Some gravitational lensing from this gamma ray source known as J223010.47. It's a galactic cluster located at about 7 billion light years. There you can see it's quite a strong gamma ray source, and there's gravitational lensing, or I'll just say lensing, associated with this area, as it's lensing a galaxy that is about 4 billion light years farther away. And we're just going to scroll down the wavelengths here, see if we can find this in X-ray. And indeed we do find the Rosat All-Sky Survey 0.1 to 2.4 kiloelectron volts X-ray flux. There is that galaxy in X-ray. And let's see what else we can find here. How about the Galix? It does have a bit of a UV signature there. Again, that galaxy located at about 7 billion light years. And there's an article about it in SciTech Daily today. Let's take a look at some optical wavelengths. The DSS-2, perhaps. How about the colored imagery? There you go. And going to longer and longer wavelengths here. How about Pan-STARRS? Pan-STARRS is one of the highest resolution surveys you'll find. It's part of a massive galactic cluster, if you were wondering. And let's see if it shows up on the 2MASS. What's the thermal spectra? And there is the thermal emission from that galaxy. J223010.47. So yeah, Hamilton's object. And check out the lensing. So this galaxy here is located at about 11 billion light years. And we're not even sure what the foreground object causing the lensing is. I would also note these lines here. These look almost like magnetic shell lines. Anyway, leave us a comment if you have a theory as to what is going on here. Look at how far away it is from the lensed image also. So here's the background galaxy, and here's the lensed image. So obviously there's something in between here that is causing the lensing. And it's, let's just say it's a little bit mysterious. Yeah. It's enough to stump the best of us. Maybe there's a magnetic field that's causing the light to be bent. Have you ever heard of the Faraday effect? Anyway, I'm just going to let the article scroll here. If you'd like to read it yourself, feel free to pause the video. We don't want the daily space weather to be too long. But stuff like this is very interesting. I've been concerned about this stuff since the mid-90s. And, yeah, I'm not convinced there is any missing matter. It's a distinct possibility that all the missing mass and matter is just simply not visible at the moment. That's today's cosmology segment. We hope you enjoyed it. Don't forget to check our playlist for cosmology segments. YouTube.com/smashamash/playlist has over 200. That's youtube.com/smashamash/playlists, where there are over 200 cosmology segments on our channel. Let's blast through some more data like charging hazards. We don't see any charging hazards. Here's the relativistic electron flux over the past year as reported by Solon.info. Feel free to pause the video here if you like. Here's a 3-day chart of the electron flux as measured by the GO16 and GO17. Nothing to write home about there. No warning levels or anything like that. Here's the forecast model, and I'm expecting an increase here in the electron flux. There's my forecast. The green boxes are NOAA's forecast for the electron flux. Next, a diagram of Earth Van Allen belts. Again, feel free to pause the video. Distances shown here in miles. Here's the total electron content forecast showing you the most likely places on Earth for GPS errors. Also giving us insight into Earth's magnetic field as electrons are only about 1/1800th the mass of a proton. They're about 1,800 times lighter than a proton, and they respond to things like magnetic field changes before the protons do. Next, another diagram of the atmosphere. Here is the diagram of where the F layer is located, the F ionosphere layer, which is where the electron flux is measured by things like the GO17 and GO16. This is the entire air column. Now we're just showing you the F ionosphere layer. Here's the ionogram of that in megahertz vibrational frequency. There's a lot of stuff going on in the bridge between Earth and space, chemical reactions, free electrons, and so on. Here's imagery of that, courtesy of Australian Government Bureau Meteorology. We'll show you the latest image. First, the anomalygram. This is departure from the 30-day median in megahertz. Some low-frequency anomalies over places like Asia, the Middle East, the North Pacific Ocean. Mostly high-frequency anomalies, however. Here's the latest image in anomalygram. That's 11 o'clock Universal Time. You can see mostly high-frequency anomalies at the moment. There's the ionogram, and there's the anomalygram. And a quick point, and thanks for letting us know, Tin Man 1057, while we did our live stream for our meteorology forecast, a large quake came in, a 6.8 in the Vanuatu region. Let's take a quick look at that before we close out the daily space weather video with our bonus features. Did it generate a tsunami? No current, warning, advisory, watch, or threat. So that's a good sign. We'll just leave it there. A 6.8 coming through. Thanks once again, Tin Man 1057. Sort of in between Fiji and Vanuatu there. All right, here come bonus features. First, El Teide, Spain's ground-based solar observatory in hydrogen alpha, 6,562.8 angstroms. Coronal mass ejection and solar flare warnings persist. Yeah, for additional ones. Here is the intensity gram, sunspot 2882. Again, this is a South Pole umbra, so this is quite significant in terms of its magnetic configuration. We may have a new sunspot forming here in the southern hemisphere. There is a new sunspot down there. We'll see if that stays around long enough to get a name. There are the fields associated with that. And here come the rest of our bonus features. More spectacular imagery from the Solar Dynamics Observatory. Here's 94 angstroms all by itself. One of the best wavelengths to observe solar flares is 94 angstroms. It takes 10 images per minute instead of only 2. Properties only available with 94 and 131 angstroms. If you'd like a close-up of that, well, we've got it. Here is the close-up in 131 angstroms. Wait for it. It's well worth the wait. Yowzers. Here's the close-up in 94 angstroms. and we work very hard to get you the best solar imagery available on the internet. Once again, thanks smAsho team for making it more likely that we will continue to make these videos and make them publicly available and free for all to view. Thanks again for tuning in, everybody. May that solar wind be at your back.